Look up at the wires running along your street. Somewhere on that wooden pole sits a dull grey metal can, humming a low note day and night. Inside it, no gears turn, nothing moves at all, yet it takes deadly high-voltage power off the line and gently tames it into something safe enough to charge your phone. It does this with 2 coils of wire and 1 quiet trick of magnetism. Let's slice one open and watch electricity change shape. Power plants sit far from the cities they feed. To send electricity across all those miles, engineers push it to enormous voltage, sometimes hundreds of thousands of volts, because high voltage travels with far less waste. But nothing in your home could survive that. Your outlet needs about 120 volts. Your phone wants only 5, so the same energy must be lifted high for the long journey, then lowered again before it reaches you. The transformer is the machine that does both. Open the can and the design is almost disappointingly simple. A ring of iron sits in the middle. Around one side, a coil of insulated wire wraps many times. Around the other side, a second coil wraps separately. The 2 coils never touch. No wire connects one to the other. The only thing they share is the iron between them. That gap is the whole secret. Energy is going to cross it without a single electron ever making the trip. Now feed the first coil with electricity from the grid. This is not steady, one-direction current. It is alternating current, electricity that reverses 60 times every second, surging one way, then the other, back and forth, back and forth. We'll spell it plainly, alternating current. That constant flipping is not a flaw to be fixed. It is the entire point. A transformer is dead and useless with steady current. It needs power that never sits still, and the grid delivers exactly that. Whenever current flows through a coil of wire, it creates a magnetic field, an invisible halo wrapping around the loops. Because the grid's current keeps reversing, this magnetic field can never hold still. It swells, then collapses, then rebuilds itself pointing the other way, 60 times a second. The first coil, called the primary, becomes a pulsing electromagnet. It pours a restless, breathing magnetic field straight into the iron core it is wound around, and the core eagerly drinks it in. Iron loves magnetism. It carries a magnetic field far better than air, the way a pipe carries water better than open ground. So the core gathers the primary coil's pulsing field and funnels it around the ring, like a racetrack built just for magnetism. The field races through the iron and arrives at the far side, where the second coil sits waiting. The core's job is simple but vital: deliver that changing field, full strength, across to the other coil. Here is the real magic, discovered by Michael Faraday. A magnetic field that changes will push the electrons inside any nearby wire. Not a steady field, only a changing one. The second coil, called the secondary, sits bathed in the core's pulsing magnetism. As that field swells and collapses, it drags the electrons in the secondary back and forth, creating a brand new voltage. Power has crossed the gap, carried by magnetism alone, with no wire ever touching another. Now the clever part: how much voltage appears in that second coil depends on the count of its loops. Give the secondary twice as many turns as the primary, and the voltage roughly doubles. Give it 100 times as many, and the voltage climbs about 100-fold. This is called stepping up. At the power plant, a transformer with far more turns on its output side launches electricity to staggering voltage, ready for the long ride across the whole country. Run it the other way, and the very same machine works in reverse. Wind fewer turns on the second coil than the first, and the voltage falls instead of rising. The can on your street takes thousands of volts off the line and steps them down to the safe level inside your walls. Even the little black brick charging your laptop hides a tiny transformer doing the same thing. Dropping the wall's voltage down to a trickle your battery can safely drink. And there is a fair trade hidden in here. When voltage steps up, current steps down. When voltage steps down, current rises. The transformer cannot create energy out of nothing. It only reshapes it, trading volts for amps and back again. This is also why the grid must run on alternating current. Steady, one-direction current would make a steady magnetic field, and a field that never changes pushes no electrons at all. Without the flipping, the second coil stays silent. No machine is perfect. The pulsing field also stirs tiny swirling currents inside the iron itself, bleeding energy away as heat. To fight them, the core is not solid. It is built from thin sheets stacked like the pages of a book, each one varnished to break up those little swirls. And that low hum you hear from the pole. The core physically flexes as the magnetism reverses, 60 times a second, a faint 60-cycle note. That sound is the transformer breathing. Follow a single jolt of power on its trip home. It leaves the plant and hits a giant transformer that steps it up to cross open land on tall steel towers. Near your town, a substation steps it part of the way down. The can on your street steps it down again to household level. Even your charger steps it down once more. From power plant to phone, that electricity may be transformed 5 times, each step handled by 2 coils and a core. So here is the whole chain, start to finish. Alternating current enters the primary coil. It builds a magnetic field that constantly reverses. The iron core carries that pulsing field across to the secondary coil. The changing field induces a fresh voltage there, and the ratio of turns between the 2 coils decides everything. More turns means higher voltage, fewer turns means lower voltage. No moving parts, no touching wires. Just magnetism, quietly handing energy from one coil to the next. 2 coils, an iron ring, and one simple fact. Changing magnetism moves electrons. That is all it takes to lift power high, carry it across a whole country, and then set it gently, safely into your hand. No gears, no fuel, no moving parts. Just a patient trade of volts for amps and back again, repeated all the way down the line. Look up at that humming can on the pole again. Now you know exactly what it is saying.